morning, students. Today we will do a chapter called Arithmetic Progression. The session's objective will be to understand the sequences, finite sequences and infinite sequences, arithmetic progression, its definition and nth terms, the sum of n terms of an AP, arithmetic mean, and insertion of n arithmetic means between two given numbers. So first of all, we start with the definition of a sequence. Sequence is the pattern making any numbers like a1, a2, a3 up to an, whatever the numbers are. If they are making a certain pattern, they are called to be in a sequence. So finite sequence is having a finite numbers and infinite sequence having infinite numbers. Series for a given sequence a1, a2, a3 up to an, the expression a1 plus a2 plus a3 up to an is called a series. So basic difference between a sequence and series is that the sequence is a collection of numbers, whereas the series is the sum of those numbers. So we will discuss in particular some of the progressions. First of that is arithmetic progression. It is a kind of a sequence in which the difference between any two terms is constant. That is, the difference between any term and its previous term is constant. The constant difference, generally denoted by small d, is called the common difference. So first term, if we let a1 is equal to a, a2 will be equal to a plus d, a3 will be equal to a plus 2d, which is d more than a2. So similarly, we can find the nth term. It will be equal to a plus n minus 1 into d. So if we have to find that the given sequence, whether it is a AP or not, so we have to follow some steps. We have to obtain its general term an, determine an plus 1 by replacing n by n plus 1, and find the difference of an plus 1 and an. If it comes out to be independent of n, that is, it is a constant, then it is called an AP, otherwise not. So before solving any problem, we should choose an AP very well. Otherwise, we will end up with a large calculation. So first of all, if we have to choose three terms of an AP, we should do it like this. We should choose the terms like a minus d, a and a plus d. If we have to choose four terms, we have to choose a minus 3d, a minus d, a plus d and a plus 3d with a common difference 2d. So this is the pattern we should follow while selecting 3, 4, 5 and 6 terms. So let us do one illustrative problem. If the sum of three numbers of an AP is 45 and the second number is thrice the first number, find the three numbers. So in this we have to choose an AP. So we will always choose, as a sum is given to be 45 of three numbers, so we'll choose the three numbers as a minus d, a and a plus d. So by doing this, we will certainly be able to delete d from the equation. So we'll end up with 3a is equal to 45, implies a is equal to 15. So after finding a, we can easily put the value of a in the product of the, or whatever the situation given to us, that the second number is thrice the first number. So in that we will put the value of a to find the value of d. So we will be able to find the numbers. Now let us discuss some important properties of an AP. If we are given an AP, by adding a constant k to each of the term, we will have another AP with the same common difference. And if we multiply each term by a non-zero constant, we will get another AP with the common difference, that constant multiplied with the previous common difference. Now we are having a very important property, that the sum of the first and the last term of an AP is equal to the sum of second and the second last term of an AP. To generalize it, we will say that the sum of terms equidistant from the beginning and end is same. We can easily find out that the first term of a given AP, we are given an AP 2, 4, 6, 8, 10 up to 20. So the first term is 2 and last term is 20. If we see that the sum of the terms equidistant from the beginning and end, like third term from the beginning and third term from the end, we find the sum, it will be 22. It is same as 2 plus 20. So in every case we get the sum as same. So another important property of an AP, if we are given A, B, C as three numbers of an AP, then twice of B will be equal to A plus C. Now we'll do a very good shortcut. In an AP, if we are given a general term that the sequence is an AP and with an is equal to capital A n plus B, where A and B are constants and the coefficient of n is A, then the common difference of this sequence will be A. We can easily prove that using a generalization theorem. Now another property, that if we select the numbers of AP at a certain interval, like we select the third term and another term after 3 terms and so on, that resulting AP is also an AP. Now the sum of n terms of an AP. So for the proof purpose, we will do a very important thing, that we will reverse the AP and add these two. So when you will reverse and add the numbers of an AP, we have already done a theorem that sum of first term and the last term of an AP is equal to second and second last term of an AP, and the general item we will denote it as 2a plus n minus 1 into d, first and the last term sum. And if we have all the terms of this sequence same, then we can multiply it easily by the number of terms it has. So in this, for finding the sum, we add up the two sequences, first in the same order and second with the reverse order. We get 2Sn is equal to n into 2a plus n minus 1 into d. By dividing the both sides by 2, we get the result of an sum of an AP, that Sn is equal to n by 2, 2a plus n minus 1 into d. This can also be written as this way, and we get the another formula for the sum of an AP, that it is equal to n by 2 into first plus last term. Another property is for the sum of the terms of an AP. If we given that the sum of a sequence which is an AP is an square plus bn, where the coefficient of n square is a, then we will easily be able to calculate the common difference, which will be equal to twice the coefficient of n square, which is in this case will be 2a. We can easily prove that. Now the arithmetic mean. If a is the arithmetic mean between two numbers a and b, then the single arithmetic mean, that is a, is that number which when inserted between a and b will form an AP. So applying the properties of an AP, we can find the value of that mean, which is equal to a plus b by 2. Now if we have to insert an arithmetic means between two numbers a and b, that means that certainly those numbers will form an AP. To find that, we have to proceed in this way, that the total numbers of an AP such formed has n plus 2 terms. So we can equate the last term of the sequence b is equal to a plus n plus 1 into d. So to find d is equal to b minus a upon n plus 1, and we can find all the arithmetic means using this formula. Now properties of an arithmetic mean. If we are given an arithmetic means a1, a2 up to an, these are inserted between a and b, then the sum of all of these will be equal to n times a single arithmetic mean between two numbers. Like we are given a illustrative problem that insert 3 EMs between minus 4 and 3. So first of all find common difference, then a1, a2 and a3 in this way. Thank you.